From Earth, Venus looks like the most beautiful star in the sky. It glows steadily, brilliantly, night after night, a soft silver light that has guided sailors, inspired poets, and filled human beings with wonder for thousands of years. But beneath those clouds lies the closest thing to hell that exists in our solar system. And the more we looked, the worse it got. For most of human history, Venus was a symbol of beauty and order. Ancient Egyptians tracked its movements with precision. The Greeks believed it was two separate stars, Phosphorus at dawn, Hesperus at dusk. Before Pythagoras realized both were the same object, the Romans named it Venus, after their goddess of love, and the name stuck because nothing else in the night sky seemed to deserve it more. Even in the early days of space exploration, scientists dared to hope. Venus is almost exactly the same size as Earth. It orbits at a similar distance from the Sun. Its thick cloud cover, some imagined, might be hidden oceans, perhaps even life. In the 1950s, science fiction writers populated it with jungles and ancient civilizations. It seemed like the most promising world beyond our own. Then we sent spacecraft there, and the dream died fast. The surface temperature on Venus is approximately 475 degrees Celsius. To put that in perspective, that is hotter than Mercury, the planet closest to the Sun, hot enough to melt lead, hot enough to reduce most metals to liquid pools on the ground. And unlike Mercury, which swings between extreme heat and extreme cold depending on where the Sun is in its sky, Venus never cools, not at night, not at the poles, not at any latitude, in any season, at any point in its slow rotation. The entire planet bakes at the same unbearable temperature around the clock without variation. It is not just hot, it is uniformly, permanently, catastrophically hot in a way that no other world in the solar system can match. But the temperature is not the strangest part of Venus. Imagine standing on the surface of Venus. Before you have time to register the temperature, the atmosphere is already ending you. The atmospheric pressure on Venus is 92 times greater than at Earth's sea level. That is the equivalent of standing nearly a kilometer beneath the ocean. The column of dense carbon dioxide above you would press in from every direction simultaneously with a force that no unprotected human body and very few machines could withstand. The Soviet engineers who built the Venera landers had to design them like armored deep-sea submersibles, reinforced with thick walls of metal just to survive the descent through the atmosphere. Even then, the surface destroyed them within hours. And then there are the clouds, those luminous, breathtaking clouds that catch the sunlight and give Venus its glow. From Earth, they look soft, almost gentle. Up close, they are concentrated sulfuric acid. The cloud deck stretches from roughly 45 to 70 kilometers above the surface, wrapping the entire planet in a permanent chemical shroud. High-altitude winds drive these clouds around the planet at speeds of up to 360 kilometers per hour, fast enough to circle Venus completely in just 4 Earth days. Rain does fall from these clouds, but it never reaches the ground. The droplets of sulfuric acid evaporate in the rising heat long before they land, cycling back upward to fall again in an endless, corrosive loop. The clouds of Venus are not weather, they are a cage. Because the real reason Venus became hell lies deep in its past. But something even worse had already begun. The answer begins with a process called a runaway greenhouse effect, and it is one of the most important concepts in all of planetary science. Venus and Earth almost certainly formed from the same raw material in the same region of the early solar system. Both likely had liquid water on their surfaces during their first billion years. But Venus sits slightly closer to the Sun. As solar output gradually increased over billions of years, Venus warmed. Its oceans began to evaporate. Water vapor, itself a potent greenhouse gas, entered the atmosphere and trapped more heat, which drove more evaporation, which thickened the atmosphere further. A feedback loop with no natural break. When the oceans finally vanished, the last mechanism for removing carbon dioxide from the atmosphere went with them. On Earth, CO2 is absorbed by seawater and locked into rock through geological processes that have kept our atmosphere stable for billions of years. Venus had no oceans left to do that work. Volcanic activity continued pouring carbon dioxide into the atmosphere, and with nothing to absorb it, the concentration climbed. The temperature climbed with it, and a world that may once have had beaches and rainfall and blue skies became the permanent furnace it is today. Not in a sudden catastrophe, but in a slow, irreversible transformation that played out over hundreds of millions of years. The surface left behind is young by geological standards. Venus has far fewer impact craters than a planet its age should. Something erased them. The leading explanation is that roughly 500 million years ago, Venus experienced a catastrophic global volcanic resurfacing, an eruption so vast and widespread that it buried the entire crust under fresh lava, wiping the crater record almost clean. With no tectonic plates to gradually release internal heat, Venus may periodically reach a breaking point and resurface itself entirely. And in 2023, analysis of archival radar data suggested that at least one volcanic vent had visibly changed shape within months, meaning Venus may still be volcanically active today. And this is where the mystery begins. In 2020, astronomers reported detecting phosphine gas in Venus's upper cloud layer, a compound that on Earth is primarily produced by living organisms or industrial chemistry. Neither explanation seemed to fit Venus. The detection itself has been disputed, with later analyses questioning the strength of the original signal, but the mystery did not disappear entirely. Venus's clouds contain ultraviolet absorbing compounds that no current model can fully identify. Its atmospheric chemistry behaves in ways that existing science does not completely explain. Whatever is happening in those clouds, we do not yet fully understand it. The Soviets were the first to physically confront Venus. The Venera program launched a succession of increasingly ambitious spacecraft beginning in the 1960s, and Venus dismantled them with brutal efficiency. Venera 7 in 1970 became the first spacecraft in history to transmit data from the surface of another planet, and it managed just 23 minutes before going silent. Later missions lasted longer. Venera 13 holds the record, surviving 127 minutes on the surface before the heat and pressure destroyed it. In that time, it returned color photographs, a rocky, angular landscape under an orange sky. The temperature gauge visible in the frame reading above 460 degrees Celsius. NASA's Magellan spacecraft, arriving in 1990, used radar to pierce the cloud layer and map the surface from orbit, revealing a world of vast volcanic plains, towering shield volcanoes, and a geology unlike anything on Earth. Future missions will go further. NASA's Da Vinci Plus will send a probe descending through the atmosphere, measuring its chemistry layer by layer. Veritas will produce the highest resolution surface maps ever made of Venus. The European Space Agency's Envision will study the planet's geological and atmospheric evolution from orbit. After decades on the margins of planetary science, Venus is being looked at again, and every new look raises new questions. But Venus may not just be a warning, it may also be a clue. A planet nearly identical in size and composition to Earth, a planet that may have had oceans and clouds and the possibility of life, a planet where one feedback loop, driven by the same physical principles that govern our own atmosphere, crossed a threshold it could never come back from. The carbon dioxide that turned Venus into an inferno is the same gas accumulating in Earth's atmosphere today. Not in Venusian quantities, not by any current measure approaching that scale, but operating through the same underlying mechanics. Venus does not predict our future, but it defines the destination. It shows us, in physical reality, what a planet looks like when its climate system breaks beyond recovery. That steady light in the evening sky is one of the most hostile places in the known solar system. Beautiful from a distance, merciless up close, a world that had everything it needed and lost it all, slowly, completely, and permanently. The most beautiful disaster our solar system ever made.